My name's Ian Gregg. I've relabeled this talk Proof of Fact because it's an emerging theme that I've been working with. So let's get right into it. There we go. If you look at all this discussion about consensus and what's happening with blockchain and what is happening around the world, there's a very small view, a microscopic view, where we're dealing with the atomic element of the fact. But there's also a very big view, a macroscopic view, where we're dealing with change in society. But we can also look at it in an evolutionary sense over time. And finally, there's a compositional view. What are the pieces working together? And I hope to at least leave some sense of that today. Finally, what's the future? And I think that's a question I hope to answer at the end. It goes back a long, long time, back to the recording of our deepest archaeology. And it starts with the question of who owns what. And this is only a recent discovery in archaeology that actually the proof of ownership was the start of practically everything. And it started with these clay balls, which were found in, I think, Mesopotamia or somewhere. And inside the ball is an animal, and that represents a token of ownership. It's baked inside a clay ball to preserve itself as a fact, so that over a cycle of production, such as a season or something like that, it can retain its fact until it's needed. Now, the evolution of that then moved to the, if you like, the simplification of the process. They stopped putting the balls around the token, and they flattened them out into clay tablets. They still baked them to lock them in, but now they were doing their recording onto a clay tablet. And from there it moved to the development of writing and the development of parchment, and finally to a thing in accounting terms that we call single entry. And that was the notion whereby the record of who owned what was placed in a single line. And it's just a list. So it suffered a certain problem, which is it's very vulnerable to errors. Whoever's making the list of accounting could make a mistake. And it could be accidental or it could be on purpose, and there was no way to tell. And then sometime around the early part of the millennium, the earliest records were at 1299 or so, but it was not fully recorded until 1494, the development of double entry accounting. And this is simply a mirroring technique where you have an entry on the left and an entry on the right. And the redundancy of those two entries made it fairly clear what was going on, especially it made it clear whether the error was purposeful or accidental. Accidental errors revealed themselves and could be corrected. Purposeful errors now created a trail of intent. And that was fantastic because it allowed us to move away from the limitations of trust that occurred in those times. In those days, you could only trust your family, so they were the ones who kept the accounts. Now that we had double entry, we could have a professional accountant come in and do the books and be reviewed and checked, which had a fantastic freeing up of energy. It meant that the rise of the great trading firms in Italy was enabled. So talking about facts, there are other facts out there. There's law. Law has a process of taking evidence and turning it into facts with rulings and examination and so forth. Science does a similar thing with scientific method, but it takes experiments and it reproduces those. And if it keeps reproducing, we call it a fact. Identity is a fact, a philosophically interesting one. Descartes had something to say. Ubuntu contradicts that. 1984 contradicts that. All of these things are very interesting as facts, but they're subjective. So, in a sense, paper and accounting, they've got something going for them that makes them a foundation of society. We can also ask, how do we come to consensus? More broadly, what sort of facts are we talking about? For whom and by what method? And also, what are the limitations? What goes wrong? How useful is this particular method? And if we come back to double entry, it turns out it's actually quite useful for enabling the growth of the firm, but the owner is the only one who can rely on double entry. These entries were not reliable outside the firm, and for that we needed other things. In the 1800s, the arisal of the professional auditor to cast a view over the internal accounts. And also other techniques. You can see the tally sticks there. I don't need to explain to anybody in London what a tally stick is. So moving forward, nothing much happened until the development of the hash. It's a cryptographic algorithm. Somebody explained it in a previous talk, so I won't go into it. But it proves the existence of something. The hash being one-to-one with a document, it proves the existence of that document. Now, these chaps, Haber and Stameta, took that a bit further and said, okay, if we chain the hashes together and we stick timestamps in there, we can start to prove the time of a document. And that's Stuart there. He's holding up last month's copy of some newspaper in New York. He's had a hash chain running for commercial purposes since about 1993. So if you think about the evolution of what we're talking about here, 1993 we've been running a hash chain with proof of existence and proof of time. So Todd Boyle came along and saw all of this going on, and he had an epiphany, if you like. And I'll just read it out because it's quite interesting for the timings. It's contra-intuitive, but by putting your general ledger rows on a shared transaction repository, remember those words, you're actually supporting a social and legal decentralization. The physical network is still hub and spoke, but the database becomes hub and spoke as well. And if you think about the blockchain today, he was predicting it right there and then. And he tried to build it. He tried to build a situation where he would take the same entry from you and the same entry with your counterparty and place them into a third-party repository. Hence, there were 3 copies of those entries with each of those trades. He was looking at the notion of invoices, the whole trade cycle, the offers, the acceptances, delivery notes, payments, all of those documents, which he was trying to turn into his fact and place that into this triple entry context. And he tried to build this, but he didn't succeed because it was a little bit too complicated. At the end of the 90s, people weren't really aware of what was possible, and there were obvious problems with it moving to scale. He failed to do so, but by accident or serendipity, I succeeded with my partner, Howland, at the time. We built a real-time gross settlement system with any asset, hence the thing called the Ricardian contract, came out of Ricardo as where the origin of the term, and it could handle cash, bonds, whatever you could write down in a contract could be issued into this system. And the way we handled the payments and the transactions was that you would do a payment notification. It was basically just a request to payment, but it was signed, cryptographically signed. That would be sent to the issuer, and the issuer would then capture that into a new document called the receipt. Now, the whole thing was in there. The receipt, from the second version, we decided the receipt would be the same for everybody. Originally, it was different for the sender and the receiver of this receipt, this payment instruction. So the receipt is now the same for everybody. It gets sent back to the sender and also sent to the recipient of the money. Consequently, we've got 3 different entries of the same receipt. And because the receipt includes the prior traffic that caused that to happen, it becomes a dominating entry. The receipt is the entire evidence you need for any question about that transaction. So you threw everything else away and you just stuck with the receipt. The receipt is the transaction, it is the entry, and hence we ended up with this term triple entry. It's fully secured. You could walk it from the actual contract of issuance all the way through to the last transactions. And it was quite interesting at the time. What we found was that cryptography and protocols and networks and the internet and all this stuff that was going on enabled us to make this one entry the same between the counterparties and with that central party to stamp the approval on it. Double entries had that failure that they weren't shareable in any reliable sense outside the firm, but these were reliable, these were shareable between your counterparties at least, and you can think of other applications. So here we've got crypto turning this data into fully shareable data, but it's also important to note Crypto was just the last piece of the puzzle. There were lots of other things going on. So Ricardo's fact, yeah, the receipt is the transaction. Said all that, interop is easy, great, move on. And then we get to Bitcoin, okay. Satoshi Nakamoto wanted a proposal. He wanted an unstoppable cash, because I and a bunch of people I worked with up until 2009 and a whole bunch of experiments getting money up on the net, we all failed. And for one reason or another, it all came down to the fact that we had a centralized server. And we saw this with different things going on. It wasn't just the government. It was also thieves, insider attacks. It was founders going crazy. All sorts of problems occurred. And Satoshi Nakamoto, they had the notion that that was the problem and came up with this notion of an unstoppable cash without a central party. So we all know that story, but it's interesting to put it in context. They also came up with a shared ledger to do this. And you can see the echo of Todd Boyle's concept of a shared repository. And the security model was such that to avoid that central party, no person can sign on. There is no vulnerable party. And the way they had to finesse that thing was to go into this notion of the Nakamoto signature or Nakamoto's consensus, where they would run a lottery to pick one person, one node, to do the signature of a block, and next time it would be somebody completely different. But what is more interesting than the consensus thing here is that they'd taken the notion, the very tight notion of an entry or a receipt, or even the little clay ball with the token inside, the animal inside it, and they'd made a big block of coins. And that was required for the scalability of their solution. So they were drifting away from where we were coming from. But it was, if you like, the first triple entry system at scale, because the blockchain then became that third party that put the stamp on. And it kind of challenged your notion of what is a third party. But what we need is the stamp of approval. We don't care how we get it, as long as we've got that stamp of approval. So without getting too deep into it, I'm sure you've all covered, how all this proof of work works over and over again. They enter a lottery, they run a selection process that way. But it's very interesting to note that the design is constructed of many feedback loops. The hashing process, or the mining process, is construct a block, hash, change the number, hash. The hash is no good, change the number again, keep going and going and going for ad infinitum until you get that magic number. That's the first one. But then the second feedback loop is you're rewarded for your block, which means you keep doing it because you can pay for your electricity. There's that third feedback loop where the other miners will build on your block, which means they might not build on your block. They might throw it away so that they move on a different block. So therefore, you've got to validate up front, and you've got some sense of being honest about it. And finally, there's this fourth feedback loop whereby, because hashing is a competitive business, the cycle adjusts after about 4 weeks and says, okay, hashing has to move up or has to move down. The point being, it's all very tricky stuff, and therefore, if you change some of it and you're not quite sure what you're doing, you can end up breaking it. And then we get to Ethereum. Ethereum went very big. Ethereum thought, gosh, only cash. Yeah, there was this thing, this promise about smart contracts, and it didn't quite work out. The smart contracts didn't actually happen with Bitcoin for reasons that we're not quite clear about. And that is actually becoming a current topic. You should watch out for that one. It's going to change. But Ethereum said, let's fix that problem, and we'll create an unstoppable virtual machine. And this was something of a computer science vision to look at what a Turing-complete machine is. A Turing-complete machine could do any program, and therefore we want to do any program, therefore that's what we should do. And I construct this as a computer science theoretical vision because that tells you a little bit about why it has taken so long to get there. However, if you think about how the fact goes with Ethereum, they've actually made it even bigger. To do a machine, you have to have a whole bunch of moving parts. CPUs and programs are very complicated, lots and lots of data. So Ethereum set themselves the task of having all of this calculation, all of this computing going on, such that it was then duplicated across thousands of machines, and they all had to answer the same question, is it right, over all of that complexity. The result is that they've got a very complex and big fact, which is way away from where we thought we were going to be. Now, it works sort of, it was a bit of a rude awakening to the community last year when they discovered that people are part of contracts, and people break contracts all the time. People change their minds. And some of the problems that you have with Ethereum basically come down to the question of governance. How do they resolve the problem of people but changing their minds? We'll get to that a bit later. Okay. Now, proof of work is very expensive. Nobody likes it. Even the people who propose it don't particularly like it, but there it is. It's the working system that was invented by Satoshi Nakamoto. How do we get rid of that? The popular thing is to say proof of stake, which means to take the amount of money in your account and vote that into the block, which is to say we choose the block by means of applying a vote proportional to the amount of money we've got in our account. In theory, it works. On paper, it looks okay. Knowing how much money is in the account is something the system already does, so we should be able to allocate that, turn that around and use that to do the block. And turns out, however, it's very hard to implement. So consequently, we haven't seen a lot of success in this area. We'll say more about that later. Where Ethereum went big, Corda, an alternate system by R3, the banking consortium, went small. Basically, the analysis that occurred there was the banks don't want proof of work. Okay, we understand that. So let's just take out the proof of work and confirm by a third party. So, you know, we're banks. We can do that. We can pick a third party, and that third party will just act well by contract. No problem. Nor do we want published accounts. So Corda actually threw away the blockchain and said, let's just use those techniques to negotiate the transaction between the direct parties. And when we get to a point where we have a race condition or a point of legality or a finality or something, then we go to that third party. So the end result is it's very efficient, very fast. But they still had this sense of fact. And now where Ethereum went extremely large in terms of the complexity of what they were doing, Corda narrowed down onto the precise transition of one contract state from moving forward from one performance point to another performance point. Very small, very tight. It's also worth pointing out that their confirmation by the notary, they brought into bear the notion of pluggable consensus. So they swept away this question of, is it blockchain, is it proof of stake, is it whatever? No, you put in there whatever you want. You can use a single server, you can use a market provider, you could use the central bank, you could use whatever seems to work in the circumstance, which separates the question out quite nicely. Let's get back to mining. There's trouble with mining, other than the fact that it's so damned expensive. The mining process, because it's so competitive, it consumes most of the block that you're in. So consequently, Bitcoin has a very long block of 10 minutes, which allows 9.5 minutes, if you like, to do the hashing, to be very competitive, to make it happen. I'm running out of time. Okay, so the other problem with Bitcoin is that there's a Sybil resistance issue in that we preserve open entry. And that was how it was invented at the start, but if we fast forward to the current time, we know who the miners are, we can see them, we go to conferences, we can spot them. So let's flip this upside down and say, okay, why don't we just select the miners? And that's what we do with delegated proof of stake, which was introduced by Dan Larimer in 2013. So we select the miners sit in a round-robin round, 20 of them say, and each one of them produces a block, which is very efficient. They get paid for it, but the question is, how do we govern that situation? Well, because it's a blockchain, we can also introduce the notion of community. They can do an election, they can do a vote, So what happens is the producers are monitored by the community, and when they get out of line, they simply get voted out by the community. The principle being here, we automate what we can, but we govern the rest. The important thing there is it sets up the notion of community, because we can now bring people into the blockchain by means of a constitution, and that allows us to set up also upgrades of the software, also arbitration, also the ability to resolve issues. It's broad, it's deep, it gives us self-governance. It's been adopted by those systems there. It's been running for 3 years for some time, so it's pretty good. So to conclude, there's that small view of the fact. This is actually the same as the introduction, so I'll race down there. We're converging on the fact. Accounting called it triple entry, or at least I did, Todd Boyle did. Finance calls it a golden copy. Payments talks about the blockchain. They're all perspectives heading to the same thing. And that same thing is, I know that what you see is what I see. So we're moving from this unshareable internal firm perspective to shareable facts, and it is actually a huge change. What's happening is that we're moving from a vertical business silo concept to consensually agreed facts on a horizontal basis. And there's a list of the different things that I've talked about. And finally, the components. It's actually, if you think about the component model, there are lots of different components. They're all interlinked, and they all help in some fashion. It's not just cryptography, it's not just hashing, it's not just proof of work, it's a whole bunch of things. So what do you see? I know that what you see is what I see. Captures the innovation. Thank you.